Hi, I'm Timothee Verdier from Wolfram Research, and today I'll be speaking about training on large datasets, which is mostly about remote training of neural networks. I think we're leaving the world of the nice and polished presentation to go to the work of the scripting and several lines of code area. And I think we're going to take risk and live on the edge because this presentation heavily depends on networks and connectivity. So that's likely to fail. But let's see. What it's about when you train neural network and you reach the stage when you're happy with what your architecture looks like on your local computer with toy example, and you think that it might be a good idea to start to go big and to train something that is more like production industrial level. Right. So several possibilities. Either you have the super duper laptop with many GPUs loaded on it and an incredible power. And that's fine, you can try on it, but it's very unlikely. And either you have to go to look for a stronger machine, and then this is the case we're going to deal with, which is either you have a strong machine, which is a server that you need to access, either you have to just rent it from web services and generate this on-demand machine for the time you need it. So yeah, why training remotely? It's indeed a bit harder than just do the net train on your computer and see those very nice and moving panels. And but it's definitely in terms of training. Definitely leads you to better accuracy and metrics. It goes much faster if you massively parallelize your computation, which is typically the GPU world, and most of the time you will need to go to that when you start to dig into hyperparameter search. You want to test several architecture, need that you want to launch many training at the same time, which is not necessarily big trainings, but many of them. So you need many machines, so you need to go to cluster for that. Or because you have the hyperparameter, the architecture you're interested in, and you want to launch a big one. And you hope it's going to be the big one, but. Okay, so typical remote training workflow, it's the same for neural network, and this is for the regular job on clusters. It's generally you have the server machine and your computer, and first step is to be able to communicate with the server. So you have to exchange some secrets that so generally something called a keeper that lets the server know that it's you, because you can do things that others can't do. So this is a little key and the little lock here. You need the scripts of the job you want to execute, and the data files in case of training. What you do is that you send a request to the server that send you this that start to check whether it's you, and if you're able to identify yourself as being you, then you open a tunnel, a connection with the server, and you can move, generally as an archive, your data to the server. And when your scripts and file are on the remote server, you will then tell the server to launch a kernel and to evaluate the scripts on your data. And eventually, the server will generate some log files and some network that you will download back to your computer. So because there is this connection involved, which can be messy, can sometimes break, and you get this pipe block thing, then you don't want to do it synchronously, which is what you have with the little nice panel. If you just connect your front end to you can definitely connect your front end to the remote kernel and just type net train, and it will work for probably a few hours, and then after a few hours of training, it would probably break because of the connection, or because you just closed the lid of your laptop and it went to sleep, and that's it. And you don't want that after, well, I assume you don't want that after a few weeks of training, like things that breaks and that's it. So as a consequence, you want to do these things asynchronously, and that's why I think the best system is the good old one with the script and so on. That's what I'm going to show you. But you don't very often have like a server with the latest GPU, or if you do, you're spending like money every year to keep it up to date and so on. So the classic way to do those things, even industrial scale, is to actually use a service provider, which job is to keep the infrastructure of those server machines. And what I'm going to show you here is how to do that by on-demand machine with Amazon Web Services, which we use internally in the team. So AWS, the Amazon Web Services, they provide a lot of services, among which you have the simple storage system, also known as S3. And S3, just you have a collection. When you create an account, you have a collection of buckets in which you can put your data. And buckets is just like an endpoint you can access with a URL. So it's a unique identifier on the whole Amazon Web System. And what you have inside is just a bunch of objects, so your data, your files, with some key, which you can see as the path to the object within the bucket to identify them. So that's as simple as that. And then you have the elastic cloud computation, also known as EC2, which you can see as like giant racks of server machines with many hardware that are there. And if you have some image, some virtual machine image, some configuration, which they call Amazon machine image, which are image of the machine configuration, and also it contains a snapshot, which is an image of what the hard drive, which they call volume, contains. Then you can request a virtual machine. So with EC2 create instance, which I'm going to show you then, a virtual machine to be created out of this image, and you end up with as a virtual machine, which is like part of the server that is allocated to you, and your volume, which is the storage part, with the server that we were talking about up there, right? So that's what we're going to do, and then the training workflow in this case. You have three components. You have the S3, where you store all your data, and it's cheap for very large amount of data. You have your local computer, in which you write your scripts and you test. Hopefully, you test them. And you have this virtual machine that you launch on the EC2 system, and for which you need to be able to identify yourself to communicate. Right, so this is previously known as servers. This is a new guy, which is the storage place, and with whom we need to communicate, and this is us. So let's start with one of the many local tests, which is like the scripter everyday life. You do the script, it doesn't work, you test it, and you do it again and again. Let's look at what I have here on the machine, and yeah, you know, not the This is supposed to. Okay, let's do it the old way. So let's just move to this. So what I have here is training data here, a bunch of images, And within those training data, I also have 3 text files. One text file, that is, let's look at them. Right. That's not very conclusive. Here you go. So you have something like this that tells which image is what, which I call the index, right? And I have some of them, which is a training deco, with like data that I want to use for training. Some of them, which is a test deco, which is more like validation set. And I have another one, which is probably a .m because it's too easy when, yeah, which is the list of possible outcomes for the classification. We're going to train a classification on these data sets, right? And on top of that, I have this script that I can just run. So it's training strip. And here we go. So we start the script. So basically what it does, it goes look at the data. It will find those text file and says, okay, this is what the index is, and then it will look for the images and it would feed a net train. We will look at that afterward. And we can, so this is running on my local GPU, and it seems to work. The training started. And I will probably have this little result folder here that start to contain what I call checkpoints, which are image of the net at a given configuration. And I have this tab separated value report, which is exactly what you see here about how the training is going on. And here we go. And eventually, I will save the result of the training once done, right? So this is a very good point, which means that we can start to think about moving to what we actually want to do, which is the remote. So for the remote, what we'll have to do, so the script is working if I have my data locally. So what we have to do is, so we have this bucket with a bunch of files, which is exactly the same configuration with what I showed you on my local machine. But you can have many, many more files. And there is this text, this train and test dictionary indexes, which are there. We get to move those data to the EC2 machine. We get to launch this virtual machine. We get to move the script there. And so we have a bit of policy privilege to set up in order for the machine to be able to talk to S3. We get to say, oh, it's OK. You can assume, you can work on my behalf. You can use my role. And we get to make sure when we start the EC2 machine that we have already set this key so that we can identify and talk directly to the machine, right? So here we go, training complete, exporting training result, and that's it. The local script seems to work, and that's I think that was the easiest one because there is no connection involved here. So let's do this. Let's generate this machine, and I will show you AWS Link, which is a wrapper that I wrote around the Amazon Standard Development Kit to do this. And then let's just do the training remotely. So let's launching an instance. How do you do that? First, you will need AWS Link. Which is in the layout, although we don't export it, so we won't, it's courtesy. We don't engage to maintain it, just a wrapper for now. And then we just very quick configuration. This is to say, here is the configuration of the machine that I want to use. That's something you specified first. So this is a configuration in which Mathematica is already installed, the old way. I just move Mathematica binary. I installed it and I activated it. Then I did this image that let me launch as like instances that repeat exactly the same configuration. This is just the role, which means that the machine is going to be able to speak to S3 in my name. So I have identification, And this is the name of the key pair, little lock, little key, in order to be able to talk to the machine, right? And a few tags which are just like some internal stuff, just saying that I am running this machine for my group so they don't kill it. Okay, so we have this. Yeah, see, the instance owner is me. That's quite easy. Okay, and so the EC2 create instance tells that I use the base configuration from the launch template, so I don't have to specify the MI. And the instance privilege and the key I'm going to use to talk with the machine. Let's try this. Oops. Some debug echo from yesterday late evening. So here we got this instance that Amazon generated for us, as simple as that. And we can just have the public DNS name that we use to connect to it. That's the machine address. We can look at its state. It's currently running. We can, and if we use datasets, we can have like all the parameter of the instance. This is a fairly powerful instance with two GPU V100. Right. So I created. So I'm in this state here, where the instance is here. It's got the key to identify me. And we are exactly here, right? Now let's move the script and let's move the data from S3. So this data move is going to be part of the script, but I have to move the script to the machine. So super simple again. Let's do it. Connecting to the instance. You can do it from the terminal, SSH and so on, or you can use remote connect from Mathematica. So what you need is provide the server address, the DNS, and just provide the path on your local computer where the private key is buried and hidden, and I won't show you. And there we go. We got a remote connection object that is that the tunnel is ready. And so we can send some oopsie. So we can send some command to see what it looks like. This is just list content at the root of my machine. And I see there's still this Linux installation remainings of I should have cleaned things, so I can do it. Let's clean my home directory. And it's just like giving the machine and showing the command as in command line. Let's see. Okay. And let's try to execute some. Yeah, okay. It's a bit slow. Yeah, connection. Let's try to execute a dummy script that is just like 2 + 2 and see whether the system is able to answer. So we have our machine and we have the state and the server is ready and we can launch a training on it, which we're gonna I'm gonna do right there, which is here is the local file that I have on the computer, and here is where I want to put it through SCP. On the machine. I want to put it on my home and under the name training scripts, and this is the identification. Okay, so I could move the script to the machine, and this is the URL on the machine, and now the only thing that I have to do is to launch the script. But if I launch the script like just run like I did here, if the connection is cut, then there is no link anymore, and it will just die. So I'm going to use a little trick that is to put this screen system that says, make it standalone and run even if I disconnect. But it's just like launching the training script. And here we go, exit code 0, standard output. And now what I can do is to use it's a bit hacky, but if I use tail, just say like, here is the training log.txt is a text file that my script generates, like what you've seen in this in the terminal before, and just look at this guy, the last 10 lines, and show me the content, creating data. So you see the script is running on the machine and is loading the testing data lists. It's creating a training progress report, loading the nets, and very soon we will see the training. While this is going on, let's make a quick tour of what the script looked like.
How do you know it's running?
Sorry?
How do you know it's running?
Because this file is created by the script. I just clean the home directory and now I have this file that I can just update. I can just update the content and see that, updating from, come on guys, seriously. So what I'm doing is I'm just loading the Wolfram, what's the name again? Image identifier net with nothing, initialize it, and training on the data for classification. So, well, looks like he needs to get it first. But yeah. We'll see so that's the training script. I guess this is the interesting part. At the beginning of it, you have this remote job queue that is just trying to see in which machine it's running, whether it's a local test or not. Depending on that, I'm just like setting the path to the data and see a bit differently, and saying like, on my machine is going to be CPU with a short training time just for the test, and on the remote machine, I'm just setting the path to the bucket that we created, that I created this week, and saying that it's going to be GPU with something that is much more big in scope. Then I'm doing this random seeding to put like everything under control regarding anything that is random, and I'm starting here. I'm using AWS command line as a run process. It's a bit hacky, but it's just to call and download the data. Like it's like the CP command from the bucket to the place I go. So I'm calling the remotes and I'm copying to local for the text files. Then I'm doing it for all the images. So this just moves the data from the bucket to my computer, to my remote machine, to the server. I load the dictionary as I was doing on a computer, and this is an interesting part. This is like how I generate the batch. When I launch the job, downloads the data, I carry on. It's asynchronous. So I start downloading the data and I launch the training. So at the beginning, I have very few data, and it gets bigger and bigger. So what I'm doing here is I look for the file names, and this is a list that increase, and then I just key take. I just take the keys in my dictionary that are the files that I already have, and I start to train with what I have. And as it goes bigger, I'm sampling more and more data, right? And then I have this function for checkpointing that just save image of the net on S3, right? And this one that generates the reports. And here is the net creation. So Wolfram image identify, net replace part to adapt to the training. And the training is super easy. It's just a net train on the net with my batch generator that just like grab some paths to the image that I have and train. Target device is GPU. And training progress function just, from time to time, evaluate, export checkpoints, and export training reports. And at the end, I'm just printing. So here is for the script. And so yeah, yeah.
So for that generate data set,
So this generate batch, yes.
Does that return file names or returns file contents?
That's a very important point. That returns file paths in the case of image, because if I do import, like import is going to be slow. It's a do everything function. So I try to avoid as much as possible import. For image, if you have a net encoder, it will take care doing it completely out of core and take care, says, oh, here is the image. I'm going to load the data just when I need it. And I don't like load everything in memory. Memory stay, quite clean.
One more question.
Yep.
Maybe it's me being naive, but at what point is this running in parallel?
What do you mean parallel? On the GPU?
On EC2, is it running in parallel or no?
Yeah, it's running on the so it's running on the GPU, which is a massive parallel system with like hundreds and hundreds of core doing this kind of convolution computation at the same time. Yes, exactly.
Can you do it without the GPU, just on several nodes manually?
Sorry?
Can you do it without the GPU, just several nodes manually?
If you have several nodes, this would require you just to export the script to every node and lodge them on every node, or have a master script that just distribute to the node. But that's something you can do if you have to train, for instance, several configuration of the network for the hyperparameter search. You can definitely do that, right? But at the moment, what I create on EC2 is just one machine. It's not a cluster. You could generate many, many machines and have one master node that distributes the jobs, like what I'm doing manually here. But yeah, actually, I think let's. Yeah, you see it download data result. Yeah, the test deco. So the download of the data happened as we can look for what's inside results. So it started the training report. It seems that that's super bad. It seems that actually yes, this updating from Wolfram server research, like loading the nets, is actually having. Let's see.
This was the failure of the
Yep.
upload of the script.
Sorry?
In fact, this was a failure of the upload of the script to EC2.
No, what we see here is what's happening on EC2. So the script started.
Oh, okay.
It's downloading data from S3. It's like everything's worked fine. But at the time that I should have locally created my little network architecture instead of trying to, like ask Wolfram to do it, because what happened here is that Wolfram said, oh, you're not up to date. You have a bunch of packets that I need to update for, and I have just 10 minutes. So it says like, oh, by the way, have you seen that neural network is a bit like, and which I should have. So it's updating from the server, and as soon as thing is updated, I will have my network and training start.
So the EC2 instance is updating itself.
Yes,
That's what's happening.
exactly. It's like I just fresh install Mathematica and says, hi, I need this network. But you see that the downloading of the data from through S3 worked, and indeed you are able to upload when the training is done, is finished.